This is a problem on precipitation reactions and describes the precipitation between two solutions. One that has 25 milliliters of a solution that has a cation represented in purple, and 35 milliliters of a solution containing an anion represented in green. There is no solvent being shown in this picture here. So the questions for this problem are, number one, write the balanced total ionic and net ionic equation that represents the reaction of lithium sulfate and silver nitrate. Part B is to use each sphere as a representation of 2.5 times 10 to the minus 3 moles of ion, and then find the total number of ions present after the precipitation reaction has occurred. And part C is calculate the mass of solid or precipitate that has been formed. So take a few minutes to think about this problem, propose a plan, and work on the solution. The plan to solve the problem can be better defined in three parts. In part A, we're going to define the precipitate formed and write the total chemical reaction. Then we're going to take that total chemical reaction as the basis to write the total ionic reaction. Once we finish that, writing the total ionic reaction, we will eliminate the spectator ions and get the net ionic reaction. For part B, we are going to count the number of spheres and determine from that the number of moles of ions left after the reaction is complete. And then we are going to convert the moles of ions to number of ions. And for part C, we're going to count the spheres of the anion to determine the moles that have formed in terms of precipitate. From the number of moles of precipitate, and from we are going to use the balance equation to calculate the and the formula weight to calculate the grams of solid that has been formed. So for part A, we will start by defining the precipitate formed and write the total chemical equation. So from the previous reaction that we had, we know that we have lithium sulfate and we also have silver nitrate. Both of them are soluble, and what we need to do is to identify which one is the anion and which one is the cation that are represented in the molecular depiction or atomic depiction that we saw in this slide. So from this the equation, we can imagine which combination will lead to a precipitate, and we can combine potentially silver with sulfate or lithium with nitrate. If we look at our table of solubility, we know that the likely precipitate is going to be silver sulfate. And that to complete the molecular equation, what we're going to have to write as the other product is lithium nitrate. We need to balance the equation, so we need to put here a coefficient of 2 in front of silver nitrate and a coefficient of 2 in front of lithium nitrate. And so then if we compare that with the atomic depiction of this picture, we know that in this particular case, the cation, which is the purple, will correspond then to the silver ion, and the anion is going to correspond to sulfate. Okay, so now we need to write, this is the total molecular equation. Now we need to write the total ionic equation. And for that one, we need to imagine which ones are in the ionic form. On the left side of the equation, both of them are fully ionized. So we want to have lithium and we are going to have sulfate. I will not put aqueous here. It's understood that this is aqueous. We are going to have silver. And we are going to have nitrate. And then this is going to lead to silver, sulfate, lithium, and nitrate. And let's see who can tell me what is wrong from this picture. What is wrong from this picture is that I actually have silver sulfate as ionized, and that is not correct because this is our precipitate. Notice that is in the solid state. So this is not ionized. This has to be expressed as silver Ag2SO4 solid. Okay, so this is the total ionic equation. The net ionic equation, we have to eliminate the spectator ions, those ions that do not change in the left side or the right side of the equation. So those will be then lithium and nitrate. So the net ionic equation will include then silver ions plus sulfate to yield silver sulfate. And since we have a more room now, we can actually add here aqueous to both sides. So that is part A. Now we are going to start working on part B. For part B, we will count the spheres to determine the number of moles of ions left after the reaction is complete. And these we have 3 green and 1 purple. So we have basically 4 spheres. And since we don't really care what the ions are, what we will do then is we are going to have to use 4 spheres. And the factor that was given in the problem is 2.5 times 10 to the minus 3 moles of ions per sphere. And since we know that spheres are going to be cancelled out with spheres and we're going to get moles and we need to have number of ions, we are going to multiply this by Avogadro's number, 6.022 times 10 to the 23rd. This is ions per 1 mole of ions. So let's check out the dimensions. Cancel out spheres with spheres, mole ions with mole ions. And if we do this mathematics, the answer would be 6.0 times 10 to the 21 ions that are left in solution in this particular problem. And this is the answer to part B. For part C, we need to calculate the mass of solid formed. So the plan would be to count the number of spheres that are part of the precipitate. For instance, we can count the spheres that are the anions. Then we are going to use that to determine the moles of precipitate from the balance equation. and use the formula weight to determine the grams of solid formed. So if we look at the picture in the original presentation, we have 4 spheres which are basically sulfate ions. So we know that we have the same conversion as before, 2.5 times 10 to the minus 3 moles of sulfate ions. For 1 sphere. We know from the reaction that the formula of this compound, of the precipitate, that we have 1 mole of silver sulfate per mole of sulfate, or that 1 mole of sulfate is in 1 mole of silver sulfate. And then we are going to use the formula mass, which is 311.9 grams of silver sulfate per 1 mole of silver sulfate. So I'm just going to cross out dimensions here. Mole of silver sulfate, mole of sulfate, and then we're going to have 4 spheres. I should have here 4 spheres. Cross that out as well. And what we have left, if we want to do this multiplication, we are going to have 3.119. We can round that up to 3.1 grams of silver sulfate, or 3.1 grams of solid. And this is the answer to the third part of this problem.